Hi, this is Alex from devstories.eu. Pillow, the Imaging Library, Episode 2 of 5. You leave a vision model training overnight, only to wake up and see the loop crashed hours ago. The culprit was a single user-uploaded image formatted slightly differently from the rest. Fixing this inconsistency before it reaches your model is the job of standardizing tensors, image modes, and conversions. Neural networks are rigid. If your convolutional layer expects an input tensor with 3 color channels and you feed it an image with 4 channels or 1 channel, the math breaks and the pipeline halts. In computer vision, standardizing your image data formats is a mandatory pre-processing step. To manage this in Pillow, you need to understand 2 connected properties: bands and modes. An image in Pillow consists of 1 or more bands of data. You can think of a band as a distinct 2-dimensional array containing one specific component of the image. For example, the red values across the entire picture form one band. Pillow allows several bands to exist in a single image object, as long as they share the same dimensions and depth. A mode is a string that defines the type and depth of a pixel in the image. The mode tells Pillow exactly what the underlying bands mean. There are 3 modes you will encounter constantly in machine learning pipelines. Mode L stands for luminance. This is a standard 8-bit grayscale image, and it contains exactly 1 band. Mode RGB is your standard true color format. It comprises 3 8-bit bands: red, green, and blue. Then there is mode RGBA. People often think of an RGBA image as just a regular picture with a transparent background. That is not how the computer treats it. Mathematically, an RGBA image possesses a complete 4th data channel, the alpha channel, which dictates the opacity of every single pixel. Here's the part that matters. When a user uploads a transparent PNG profile picture, that image arrives in your pipeline as RGBA. It carries 4 bands of data. If your image classifier expects an RGB tensor, feeding it that raw PNG will immediately trigger a dimension mismatch error. You have to standardize it. You accomplish this using the convert method. When you call the convert method on an image object, you pass the target mode string as the argument. To fix our PNG problem, you open the image, then call convert, passing the string RGB. Calling the convert method does not alter your original image in place. It returns a newly constructed image object containing the translated pixel data. The conversion process is not always a simple deletion of extra data. When you convert an RGBA image to RGB, Pillow drops the alpha channel, but it does not magically preserve what you thought the transparent background looked like. By default, Pillow replaces the transparency with black. If you convert an RGB image down to mode L for a grayscale model, Pillow does not just lazily average the 3 color bands. It applies a specific weighted mathematical formula to the red, green, and blue channels to calculate a highly accurate human-perceived luminance. The resulting mode L image has exactly 1 band. If you call convert and request the mode the image is already in, Pillow simply returns a copy of the original without wasting compute cycles. This means you can blindly run a convert to RGB command on every single file in your dataset without worrying about penalizing the ones that are already formatted correctly. Always assume user-provided images have unpredictable channel depths. Enforcing a strict mode conversion at the boundary of your pipeline is the cheapest insurance policy you have against runtime dimension errors. That's all for this one. Thanks for listening, and keep building.